Hi guys, let me give you some hints here to complete question number 10. The diameter C of a randomly selected large drink cup at a fast food restaurant follows a normal distribution, so I'm going to write that down first. C is distributed normally. Mean of 3.96 inches and a standard deviation of 0.01 inches. The diameter L of a randomly selected large lid at this restaurant also follows a normal distribution with a mean of 3.98 inches and a standard deviation of 0.02 inches. For a lid to fit on a cup, the value of L has to be bigger than the value of C, but not by more than 0.6 inches. That's particularly important. So what is the probability that a randomly selected large lid will fit on a randomly chosen large drink cup? So step one, you want to think about the difference L minus C. So let's think about what L is. The question says that L has to be bigger than the value of C. Fair enough. So they can't be equal to one another. So if we think about what we're interested in here, if they are equal to one another, the lid will not fit the cup here. So I know that the difference between them must at the very least be positive. It must be L must be just a little, ever so slightly more than C. So 0 would be a good boundary number here. In particular, 0 should be smaller than L minus C. Of course, that also says that L minus C is greater than 0 if you read it the other direction. So if they're equal to 0, they're exactly the same size and they won't fit. L has to be bigger than the value of C. So this statement gives me one of the values to which I want to compare. But I want L to be bigger than C, that's true, so I want this difference to be positive, but I don't want that difference to exceed 0.06. So on the high side, I have 0.06. So I am not interested in that difference being more than 0.06. So what I want for my lids to fit, I want that difference to be less than 0.06. So of course this says, but not by more than 0.06. So apparently in this case, less than or equal to would be okay. So of course, this 0 and this 0.06, these are simply boundaries, and this is a continuous random variable, so it doesn't really matter whether the 0 is included or not, whether the 0.06 is included or not, because ultimately, if I want to find this probability, I need to find the distribution of L minus C, and then I can find the probability that that random variable is between these boundaries of 0 and 0.06. It doesn't so much matter whether I include the boundaries or not. So by values of interest, we're talking about these values of 0 and 0.06. Now, the key to this question, though, is to understand the distribution of L minus C. So both of them are normally distributed random variables. So L minus C is a linear combination of two normally distributed random variables. So it will also be normally distributed. What you need to do is find its mean, and you need to find its standard deviation. So literally its mean is mu of L minus C. The standard deviation is lowercase sigma of L minus C. And this is something that we have reviewed recently. So the mean of the difference of two random variables, something to think about, the mean of the difference of two random variables, we can find that simply by taking the difference of the two means. I know the two means, so I can take the difference of those two, and that will make the mean of my normally distributed random variable. So it is important that we believe that these are independent random variables. So it's important that the random variable L is independent of the random variable C. If that is the case, then the variance of L minus C, even though we're taking the difference of two random variables, that variance is still found by adding separately the variance of L to the variance of C. So even though we're taking the difference of two random variables, difference is technically still a sum. You can still consider it as adding the opposite of C. We are still combining the variability in L with the variability in C. So we want to combine those variances. Notice that those variances can be found. They are up here. So this is the standard deviation for L and the standard deviation of C. So we can square those to find the variances, then recognize that what we want, though, isn't the combined variance. We want the combined standard deviation. So to do that standard deviation, then we're going to have to take the square root of what we get here, the variance of L plus the variance of C. We'll add those and then take the square root. That will give me the standard deviation of my random variable, and now we're good to go. So at this point, then, we will have boiled down the question to something that everybody should be able to do. So instead of a question involving L minus C, we can reconsider this question in terms of z-scores. So we can take L minus C, we can find the z-score for 0, 0 minus the mean divided by the standard deviation. We can find the z-score for 0.06. Again, 0.06 minus the mean divided by the standard deviation. We can literally turn this question into a probability question based on z-scores. So I'm not going to tell you what those z-scores are. You need to calculate the mean and the standard deviation and find those z-scores. So understand then, those z-scores will give you boundaries that you can use to find the area under the normal density function, and you can use that to represent the probability. So this is a situation where you want to draw a picture. That picture represents the bell curve. You want to label the center as 0. That's the center for z-scores. You want to label the standard deviation as 1. That is the standard deviation for z-scores. You want to mark these two z-scores. Those are the two boundaries. You want the area in between them. Then you can use either the shade norm command or the normal CDF command in order to find that probability, in order to find that area. So something to think about. Let me call up my calculator here. There we go. If you press the program button, you should have a program named normwin or something similar to it. If you are going to use the shade norm command, you need to run this command first. What this will do is set this window. This is the window that helps you see the standard normal distribution best. So if you have this window set, it would also be good to press second y equals and make sure that your plots are turned off. Notice that right now I have a couple of plots that are turned on, so I would advise you to do the same thing that I am doing. Make sure that your plots are turned off. Otherwise, you're liable to get an error if you run the shade norm command. Let's check now. Good, looks like my plots are off. Now we would be good to run that command by pressing second variables. You can go over to draw, and there's the command that we have used. You could also use the normal CDF command right here. It would use the same lower and upper boundary, the same z-scores that you would use in the shade norm command. The difference is this will give you the area under the density function without showing you the picture. Either way is a perfectly acceptable approach to completing this question. So those are my hints. Hope this has been helpful.